Okay, H2 Ports, it's an initiative that aims to try, the main objective is to try the hydrogen technology in a port. So the impacts that we expect from technology, these tests, you can divide them in two types of impacts. Some of them related to the technology itself, such as the test of and the introduction of fuel cell at ports, and the validation. And the project aims for the industrial partners even to reach the level of development that allows them to introduce the products in their catalog. And the project will also deal with some cross-cutting issues, which are really important, such as safety, acceptance, feature adopted, and so on. With this slide, I would like to just really briefly highlight the interest of hydrogen in ports, the future of hydrogen in ports, and why also ports can play a huge role in hydrogen technology development. You can see that there are a lot of opportunities for hydrogen technology at ports. Ports have heavy consumers, large consumers with captive fleets, such as the terminal machinery of vessels or trucks visiting the port, or trains, even trains. And you can easy the logistics of the supply for all those applications. So that is a nice starting point for hydrogen technology. Some ports also have like really big hydrogen consumers, some industrial ports. And also there are some plans of installation of renewable energy in ports, such as the plans of the Port of Valencia, which aims to install several megawatts of renewable energy in the following years. And in that scenario, also hydrogen makes a lot of sense. And finally, ports are normally really close to cities, so they can be the initial push for hydrogen technology to even be adopted in the cities. So with that in mind, we started with H2 ports, and the Port of Valencia, you can see a picture. The main traffic that we have are containers. We have 3 big container terminals, and for that reason, it made a lot of sense to start with hydrogen technology, using it in terminal equipment. In the projects, 2 different types of equipment will be tested: the reach stacker for a container terminal, and the Port of Valencia also have an important roll-on, roll-off cargo. And we have a very important terminal, and the other pilot will be tested in that terminal, terminal tractor. Since both terminals are not close and the equipment cannot exit the terminal, we also had to develop mobile solutions for the refueling. So the project also includes the mobile hydrogen refueling station. We are going to see some details about each of the pilots in the next slides. Very important is to have a good consortium, and I think we have a great one, in which we have all types of key players for such projects, such as the president of public authorities or research institutions, industry, and we have important players such as Hyster-Yale, Ballard, or Enagas. And very important is to have the involvement of end users of the hydrogen. Companies that believe in the future of hydrogen and would like to try the technology in real operation in this case. So we are very lucky to have in the projects MSCTV and Grimaldi Group, which both think the technology is a good solution. This is very briefly, the project structure is 6 work packages, and 3 of them are more transversal, and the other 3 are related to the pilot. Some details about the pilots. this is the solution for hydrogen supply. The most important part is the mobile unit. We need it to be mobile to be able to reach the terminals. And the project do not include hydrogen, on-site hydrogen production. So the project will receive the hydrogen from outside, from our external supplier, and it will receive it in a buffer tank, which will have more or less 3 days autonomy. So we will have to receive external truck with hydrogen every 3 days, more or less. And we also will have the compressor in the static part. The compressor will raise the pressure up to 2 levels of pressure because the refueling will take place using difference of pressures, and we will have 2 levels of pressure, 300 bar and 440. We have 2 stages for energy efficiency reasons in the mobile unit, and the mobile unit will visit each terminal once per day. The responsible of this pilot is the Centro Nacional del Hidrógeno in Spain, and a lot of several partners also participate, such as from ourselves, the Ports Valencia, MSCTV, Heister, Grimaldi, and Negas. It is designed to be able to deliver up to 60 kilograms of hydrogen per day. The next one is the Rich Stacker, which is being developed by Heister Yale. Heister Yale is also using the experience that gained at the Port of LA with the development of top loader, which is a similar type of machine, but the raising and the lowering up of the containers are vertical instead of in this case. It has been the design of the Rich Stacker. It's really advanced, and it has been very important, the constant dialogue between the manufacturer and the end user in order to define and to identify all the needs that the final user has in order to guarantee a good acceptance of the technology by the final actual users will be the port workers. And finally, the second pilot is a terminal tractor with 4x4 traction. It has to be a 4x4 because it has to ramp up ramps that have the vessels in which the terminal tractor operates. And it makes it to be more challenging because that means higher consumption for the same space. So if you want to keep the autonomy, you have less space to put everything inside, and that has been challenged during the design of the hydrogen version of the terminal tractor. And now the design is almost finalized, although they are still working for that. And as the partners, we have Athena, which is the leader of these work packages, and also the end user, which is the Grimaldi Group, Centro Nacional del Hidrógeno, Fundacion Valenciaport, and also Ballard as fuel cell provider. So this is a brief description of all pilots. As the planning, we started the project in 2019. So the hydrogen refueling station is being constructed right now, and it is in the final stages. So we expect it to have it ready at the beginning of 2021. And the design of the other two is already taking place, but the Rich Stacker is a new design, which is also almost finished, and the terminal tractor is a retrofit, and so some parts are not included in the design. In both cases, we expect it to have after summer next year, and then it will start a 2 years testing period in real operation. So we expect it to finish at the second half of 2023, when we'll finish the project. So thank you very much. If you have any doubt, you also can visit the webpage of the project if you want more details, but also I will be happy to answer any questions you may have.
Okay.